So in this video, we're going to look at Riemann sums and trapezoid rule. So the definition of a Riemann sum states that let f be defined on the closed interval from a to b, and let delta be a partition of a to b, given by a is equal to x of 0 is less than x of 1, less than x of 2, less than x of n minus 1, less than x of n, which is equal to b, where delta x is the width of the ith subinterval, so x of I minus 1 to x, and if c sub I is any point in the ith subinterval, then the sum of fc sub I delta x I from 1 to n, and x of I minus 1 is less than c sub I, which is less than or equal to x of I, is called a Riemann sum of f for the partition delta. The sum is in section blah. Okay, so here, this is important. It says that delta x is equal to b minus a over n. And this is important for solving many questions because you'll need to find delta x. And this gives you what delta x is in relation to b and a and n. Okay, so this is what Riemann sums is. And then furthermore, in some cases you'll need to find what the right Riemann sum is. And that's just asking for what the sum would be if you wanted to find the sum of rectangles that are the right Riemann sum. So if we were to draw a little sketch right here, the right Riemann sums would look like this. So this is the graph. The right Riemann sums would have their point right there, and the next point would be here, and then the next point would be here, and this is all assuming that, so this would be delta x, delta x, delta x, delta x would be in between all of these. And then since there are 3 rectangles drawn here, the n would be 3. Yeah. So this is the right Riemann sum, and the equation for that is the sum of f of a plus I delta x times delta x, and that's the sum of that from I to n. And we'll actually work with problems involving these in a minute. And the left Riemann sum is f, the sum of f of a plus I delta x times delta x from 0 to n minus 1. And then, like the right Riemann sum, let's try to draw the same picture here. Okay, so if this was the graph, the left Riemann sum would be, see, the far left would be, or actually I should probably do it like that. Okay, the far left would be 0, so this is 0. For here, the left point is right here, so that's where this rectangle would go. The left point here, and the left point here, y value here, and it would look like that. So this is the right Riemann sum, and this is the left. Okay, and then we have one more Riemann sum, and that is midpoint. And midpoint is the sum of f of a plus I minus 1/2 delta x times delta x from I to n. And then what that would look like on a graph. The graph looked like this, and these are, each one of these would be delta x. For the midpoint, you would say you want here, the midpoint from this point to here is this value, So that's what the height of your rectangle would be. So here it'd be right here. Here it'd be right here. And for here it'd be in the middle here, so I'd say it's probably right there. And it would look like that. So these, the picture might be a little bit off, but these, like, part of it should be inside and part should be outside. Yeah. And this is midpoint. Riemann sums. Okay, so those are the three Riemann sums, right, left, and midpoint, and you'll need to know those equations. Also, a way to remember these equations easily is delta x, just think of it as the width. So delta x is just the x value, or delta x, as we said earlier, is b minus a over n, and that's, just think of that as your width, and then the f of this value inside here, think of that as your y value. So when you multiply these together, you're getting the area of a rectangle. So from 0 to whatever your upper value is, that's going to be the area of the number of rectangles you have, and for each specific rectangle. So we have one more to cover, and that is the trapezoid rule. So here in the trapezoid rule, this talks about how to find find the area of a trapezoid. So I think the easiest part to learn this is to just look at the rule. Okay, so the trapezoidal rule states, let f be continuous on a to b, and the trapezoidal rule for approximating b of a, the integral of f of x dx from a to b is f of x, the integral of f of x dx from a to b is equal. The area of a trapezoid equation is just area equals 1/2 times base times height 1 plus height 2, or you can think of it as area equals 1/2 times height times b1 plus b2. And these y values would be your bases that you're adding together, and this would be the height, or this would be the height. So in this equation, it's basically just how they rewrote finding the area of all the trapezoids, and then respective to like the number of trapezoids. So let's try working on a problem. Let's see. All right, let's try this one. So y is equal to 1/8 x squared plus 1. 0 is less than or equal to x, which is less than or equal to 4, and use 4 rectangles. Oh. There we go. So the first step you need to do is you need to find delta x, c sub I, f c sub I, those three things. So delta x is equal to b minus a over n, and the b in this is 4 minus 0 over, n is the number of rectangles, and that's 4. So 4 over 4, which is 1. C sub I is a plus I delta x. And the c sub I in this case, let's just say we're solving for the right. There. So this is going to be equal to 0 plus I. Okay. Now let's write our equation. N I equals 1 f c sub I delta x. So we know n is 4 f c sub I. So you're just going to plug in this value to the f of x equation for x. So you get 1/8 I squared plus 1 times 1. So then you're gonna get 4 equals 1, 1 I squared over 8 plus 1. And then you'll want to split it up using the summation properties. I squared over 8 plus 4 delta, sorry, my bad, sigma, not delta. And then you can factor out the 1/8 since it's a constant, so you're left with I squared. And this is going to be 4, since that's one of the properties. And make sure the 1/8 that you don't multiply by this whole thing. The 1/8 is only for this one part here. So make sure you don't make that mistake, because I do that sometimes. So then we use another one of our properties. I squared, it's going to be n plus 1 to n plus 1 over 6. And don't forget the plus 4. And the n in this case is 4. So 1/8, 4 times 4 plus 1, which is 5. 2n plus 1, 8 plus 1, 9 over 6. And then plus 4. And we can actually, let's see, we can make this a little easier to solve. This is 2 and 3. This is going to be 2. So you're going to get 15 over 4 plus 4. Which is going to equal 31/4 or 7.75. And this is going to be for the right Riemann sum. Okay. So now let's try to find the left Riemann sums. So that delta x is going to remain the same. The c sub I is going to remain the same. This part right here is going to be different. So let's rewrite that. This time it's going to be n minus 1 as the upper value. And then f c sub I delta x, and it's going to start at I equals 0. So then n minus 1, n is 4, so 3 I equals 0, f c sub I. We did it right here, so we can just rewrite this. I squared over 8 plus 1. And then split it up again. Or actually, this is where you could use another method. Let's see. Okay. Here you can use another method. We don't know how to find the values starting with 0, find the sums starting at 0. We only know how to do it with 1. So we can get rid of this problem by finding out what the value is when I is 0. So when I is 0, you plug it in here, you get 1. So that's our value when I is 0. So we can just start this from 3. I equals 1. I squared over 8 plus 1. And then we're going to add. Okay, yeah. So that makes up for starting from I is equal to 1 instead of 0. So that's why we add another 1 there. So then when we solve this, we get, or when we simplify this, we get 3 I equals 1 I squared plus over 8 plus 3 I equals 1 2. And then this value here, it's going to be 3, oh, my bad. You factor out the 1/8, since it's the constant. I squared, that's the property, n plus 1 times 2n plus 1 over 6, plus this is just going to be 6. Oh, and you don't need this anymore, because this is equal to this whole thing. So you don't need to write the summation notation again. N in this instance is 3. So 1/8 of 3, 3 plus 1, 4. 2 times 3 plus 1, 7 over 6 plus 6. We can simplify here too. 2. So you get 7/4 plus 6. And that should get you 5.75. Let me double check this really quick. 6, that's not right. Let's see where the mistake is. This should be 3 times 4 times 7 over 6. 1/8 plus 3. Oh, this plus 1 should not be in this summation. This should be outside of it. So this should still be 1. So outside all this is a plus 1. So this isn't going to be a 6. This is just going to be a 3. Just going to be a 3. And then you're adding 1. So this is going to be 4. And then it's going to be 5.75. Yeah, that was my mistake. So when I is equal to 0, when you're using, when you're looking for that value, it's just going to be 1, and it's going to go on the outside, because you don't need to find the sum of that number and everything else. You can just add that in.